All right, we're back. Hey everybody, Michael Zull here again, doing a video tutorial series for West Side Electronic Music. This is part 2 of our Wwise to Unity integration series. Last time we covered some basics of working in Wwise and Unity, coming from the perspective of a noob to the game audio world. So this time we're gonna create some ambient sounds in Wwise and get them into our Unity project. We'll work a little bit with 3D sounds versus 2D sounds, and kind of go over the concept and how to set those properly in our Wwise and Unity projects. We'll create some custom attenuations and all of the options that go along with those. And we're going to be working with one particular sound effect that happens in multiple different instances around our map. So we're going to work on preventing repetitive audio from that sound effect and prevent phasing issues as well. So the coffee's a brewing. Got my first cup here going, so ready to dive into some Wwise and Unity this morning. So without further ado, let's get started. Okay, so last time we worked on some basics with Wwise and Unity, and we're able to integrate our Wwise project into our Unity project, editing the first-person controller script to reference the audio kinetic sound engine for the footstep sounds. And so we'll go ahead and playtest our handiwork from last time and talk a little bit about what we'll work on today. There's our footstep sound, very repetitive and doesn't change with our terrain, and we're going to be working more on that in a later video. We'll get way in depth with the footsteps and get them all tweaked out the way we want. And one of the things you'll notice in this map as you fire it up and walk around is you're going to see these torches all over the place. And there's no audio coming from them right now. So we want to get a torch sound effect going for all of the instances of this torch, within the map. We want those sound effects to be 3D in nature. So when I walk by this one, I want to hear it, on the right side and rotate around me as I turn. And I also want each one of these torches to, not be the exact same sound effect, playing at exactly the same time, looping in exactly the same way. We want to get some variation going with those so that they sound unique from each other. And that's what we're going to do. There's plenty that we can do about that in Wwise to get that happening. So we're going to go ahead and back out here and pop into our Wwise project and make that happen. So the first thing we're going to do is we're going to import our torch audio file. And I don't think I covered this last time, but you can just drag and drop files into the importer. And you'll see our options here. This is really handy for importing large numbers of files. You can import folders and set various types of Wwise objects within the importer, and it will save us some time. In particular, later when we're working with the footstep sounds, we'll have several folders full of files that correspond with the various terrain types that we're running on, and importing all of that in via the importer with the files organized into folders, we'll be able to set up our object and sound effect structure right from the importer, rather than having to create all of those objects individually. So we'll go ahead and import. I already imported this into the project before, so just hit OK. It's overwriting it. And we'll cover just a couple things here real quick before we start setting up our basic event. We're going to start with doing just a basic event to show you the less sophisticated way of getting this sound effect going in Unity. And so let's do it. So first off, we were talking about, we want our sound to be 3D, not 2D. The best example of 2D sound and game audio that I can give you would be music. Say you're, playing an RPG and you're running around the map, and there's all sorts of 3D positional audio happening. You hear a guy, the guard yelling at you to get out of the town or whatever, 50 yards ahead of you. But the music is just coming through both speakers kind of in a God mode sort of way. It's not positional audio. That's 2D audio right there. So that's not what we're doing here. We want these to be emanating from an object, emitting from an object in our Unity project. So we'll change this to 3D. And when we do that, we're going to see our attenuations get ungrayed here so that we can work with those. And we'll start working with attenuations the proper way right from the get-go using share sets. And we probably don't need to for this sound effect, because for the torches, we're going to use a custom one just for this sound effect. But this will give us an overview of what share sets and attenuations are for, or how they work. So in my default work unit here, in my share sets are, you can share settings across different objects in your Wwise project. So I could create an attenuation, and I can apply it to several different sound effects or containers, anything that I want. So we'll go ahead and create a new child attenuation, and we'll call it torches. And double click it to open it up. And here's our attenuation editor. And you'll see down here that the distance ruler. And this is in game units. And with Unity, I believe the game units are 1 meter. Pretty sure about that. Not 100% sure though. And depending on the map that you're working with, if the developer changed what the game unit size is, you're just going to want to experiment around with, that's been my experience, is I had to, experiment with, different with the game units to just kind of find out what worked, what sounded realistic to me. And that'll give you a better idea of how you can move forward with using attenuations. So for this torch, let's go ahead and set a max distance of 20. That's the maximum distance that I'll hear this torch sound. And I guess technically that should be 20 meters away. I'll start hearing this sound. And here is our attenuation ramp. And we can add breakpoints to this and change the attenuation curve. So I will do that. I want to kind of hear it from some distance, but I want it to ramp up a little more as I get closer to the torch. And we'll add one more thing in here as well. We'll add a low-pass filter, define a custom one. As you move away from a sound source, in the real world, the less you can hear the high frequencies, they get attenuated. So the low-pass filter simulates this phenomena. And what we can do is, let's go back to our sound effect, and we'll go ahead and play that. And did I assign this to the torch yet? General settings. Oh yeah, positioning. Let me set this to our torches. This is the attenuation we're working with. We'll edit that again, and now we can preview our torch and see what our attenuation is going to sound like. Very good. And just to show you what the low pass filter does, I'm going to just exaggerate it so we can see the effect. You can see the further that we get away from the sound source, the less high frequency content we can hear. So we won't ramp this up quite as much. We'll leave that at about half. And we don't have this. I'm going to have to play it again. That's one more thing we'll have to look at before we push this over into Unity. Hit Control here, and I can see both of our curves. Lovely. That'll do just fine for now. So, last thing before we push this over is, these torches never stop burning. We don't want them to just play a single instance of the torch, but rather have them loop. So in our general settings, we want to check the loop box. It's going to loop infinitely. And there we go. So we have all of the settings for our sound effect and our attenuation set up the way we want. So now we just need to set this up on an event so that we can push it over into our Unity project. So go to our events, put this in the default work unit, new event, call it torches. And I'm going to create a new sound bank. Looks like I already did. We'll do it again though. A new sound bank for these ambient sounds that we're going to create over the next couple videos. Our footsteps are in their own sound bank, and we'll make a new one just for organizational purposes of our ambient sounds. So there's a new sound bank. F7 gets us over into our sound bank layout, but we don't want to be there yet. Let's go back to our designer layout. There's our torches event. We want to grab our torch sound, throw it into our event, then go back to our sound banks and drop our torches event into our ambient sound bank. So we'll check this off. We want to generate them both. All of our settings are correct. We will generate. There we go. Footsteps is already up to date. Or created this ambient sound bank and updated it. And no errors down here, so we're good to go. So we're going to pop back over into Unity and check out what we got. Okay, so we're back in our Unity project. We generated our sound banks with our torch sound in Wwise with our torches event into a new ambient sound bank. And we can see in our Wwise picker that our project has been updated with those Wwise objects that we created, our torches event and our ambient sound bank. So we're going to attach this torches event to all of the torch objects that are within our game world here. So I can go over to my props. There's my torches fires. And you can see that there's all of the instances of the torches within the map. So I'm going to go ahead and select all of these. And you can see they're all selected. And simply drag the torches event into the inspector to add these scripts to each one of these game objects. So it automatically adds the AK ambient script. Ambient is basically just a sound source. This is triggering on start, so when the map loads, this script is going to play. It's going to play this event torches, which is our looped audio event that we created over in Wwise. It also attaches this game object script, and what you're going to notice here is you see the red text for this environment needing to have a rigid body attached for the environment aware checkbox. And what environment aware means is that this sound source will be reactive to reverb zones should we have them created in our project. And we'll talk about reverb zones in a later installment in the series. So say you had these torches in a hallway of a castle or something, and you had a reverb zone set up there, and you wanted the torch to have a bit of reverb, as a result of being in that hallway, then you'd want to have the environment aware checkbox checked, and you would need to add a rigid body component to this game object as well. We won't be doing any of that with these, no reverb zones or anything like that, so we can just leave that as is. It's annoying to see that red text there, but it's not going to affect us in any way. So let's go ahead and play test this to hear our torch sound effects. And we're running up to our torches, and oh my, we can't hear our torches. Why is that? Well, there's one thing we forgot to do, and that is load our sound bank for our ambient sounds into the map when the map starts. Our footsteps are attached to our first-person controller that contains all the footstep sounds that are being emanated by the first-person character. So organizationally, it makes sense to just attach it to the first-person controller. But these sounds we're just going to drop into an empty game object that we'll create. So I'm just going to create an empty game object, and I'm going to call this sound banks. And just for giggles, if I ever need to find it, I'll just pop it, close to our start point of our map over here. That's just fine. And on this game object, we're going to add our ambient sound bank. It's going to load on start. You can just unload on nothing, and it knows which bank name to load. So now when we start the map, it's going to load up the sound bank, the ambient sound bank, which contains our event for the torches, which references the sound effect of the looping torch audio. So now we should hear this in our project. And we run over to our torches, and there we go. We have torches. So we were talking before at the beginning of this video about repetitive audio, and that's what we have here. You know, we have two different instances of the torch playing, but we can, you know, hear it in both ears. But it's the same loop. It's exactly the same, very repetitive, no variation at all, and that's not going to be realistic. You know, torches don't burn exactly like each other. So we're going to need to do something to get some randomization, some variation going with each one of these torches so that they're unique from each other, which will, you know, add to the realism of the effect that we've created. So there's plenty we can do about that in our Wwise project to fix this problem that we have. Okay, so we're going back to our Wwise project to work on some randomization, some variation in these torch sounds that we've created, and I'll show you a few different things that we can do to help make these sounds unique from each other. So the first thing I'm going to do is I'm going to create a new random container and call it torches. What a random container does is, you know, you place, in this instance, you know, if we have a bunch of different sound effect files, you know, in this random container, whenever this container is triggered, it's going to randomly pick one of those files to play. So what we're going to do is we want to create some more torch sounds to be played randomly. You know, whenever each instance of the torch object goes to fire up its looping torch audio, it's going to pick randomly one of these sound effects that we create and apply it to that game object. And if we make those unique from each other and they're spread around the map, then we'll get, you know, the illusion of you know, randomization, of, you know, them being totally different from each other. So the first thing we'll do is we'll copy this, and we're going to make 4 instances of it. So we'll just paste it, paste it, paste it. So there we go. And what we want to do is, you know, as you saw before, all of these sound effects as they are, you know, are looping exactly the same. These are just copies of each other, so they're starting at the same point, stopping and looping at the same point, and we want to change that. And we'll do that in our sound bank editor, or excuse me, in our content editor. So we'll change back to the design view so that we can make some changes here. We'll leave our first instance as is. And we'll make 01. We're going to change our start and stop loop points. So we click on our waveform down here, and it brings us to our source editor. And we're just going to create a different start and stop point for these other instances of the torch effect that we have in our project. Get it nice and close, and you know, you want to, normally when you're cutting audio, you want to you know, make the cuts, you know, at 0 crossings. So we just want to put tiny little fades here so that we don't get pops when it loops. And tiny little fade. There we go. So there's a new loop of our audio. Same sound file that we're using for all of these, but starting and stopping at a different point. Or, you know, starting and looping at a different point. So they will sound different from each other. And we'll just do the same for the other two. You know, something like this. You know, add a little fade. Little fade in. Little fade out. And we'll do one more. Just totally random, you know, edit that I'm making here just to have them be different from each other. So we'll do something like that for this one. There we go. One more thing we want to take a look at, since we have created copies of this file and put them into a container, is we'll look at parent-child relationships. So if we have the torches random container highlighted in the contents editor, in the property editor, and our positioning defaults to being 2D. And we don't want that. We still want these torches to be 3D sound sources. And you can see if we go to one of the torches that now it has changed from being 3D that we had before to being 2D. And that's because it inherited the properties of its parent. Now, if we wanted to override that, we can just click the override and change it to whatever we want. But we just want all of these to be 3D and use the same share set attenuation that we used before. So we just changed the parent, and we should be all set. And you can see our randomization here. It's just going to do a standard random play. We don't need to change the avoid repeating. We only have 4 instances, so not a problem. These are all set still to loop infinitely. And we should be good to go here with creating some randomized torches. One more thing we'll do is we'll look at pitch randomization. So here's our pitch. We play one of our sources. Here's our torch. I can pitch this up or down. Let's go ahead and put that back at 0. Right there in the general settings, pitch, low pass filter, and high pass filter settings. We want some randomization going here. So this little circle with the line through it is to randomize, and we'll enable the randomization. And pitch is done in cents, musical cents. 1/100ths of a musical interval. So we don't want this to be too much variation, just a little bit, so we can have it vary between 50 and -50 cents of pitch variation, away from our center standard pitch. So that's going to make each one of these play just a little bit different from each other. And that, coupled with the fact that it's playing randomly one of these different sound effects that we have, starting and stopping at different loop points, is going to create some nice variation and make each one of these torches unique. So last thing we're going to want to do here is go to our torches event, and rather than just playing the torches sound effect that we had before, we want it to play this random container. We'll go ahead and replace that. So every time this event gets called up, it's going to pull one of these sound effects from this random container and play it from that object. We'll go ahead. Anytime you make changes in your Wwise project, you need to update your sound banks so that you can push that over into Unity. F7 gets us back into our sound bank manager, and we will go ahead and generate. See that our ambient sound bank got created, updated, and no errors, so we're all set. Okay, so we'll move back over to our Unity project, and we're going to check out the result of our randomization of our torches. So this should all be updated. The same event that we've put on each one of these torches is now just referencing that random container. So we shouldn't have to change anything else. We should just be able to go ahead and play test this and hear some randomized torches. Let's run toward our torches, and there we go. You can hear distinctly in the left and right channels these 2 torches positioned in a 3D manner, and they're starting and stopping their loops at different points. There's a little bit of pitch variation going on, so they're different from each other, rather than just playing the same sound file and sounding exactly the same. So there you go. That's good stuff. We got some randomization going. Randomization is a huge part of doing game audio. You want to make sure that you don't have repetitive sound effects playing all the time, or it starts to sound very stale and doesn't sound realistic at all. So as we move forward in the rest of our video series, we're going to be doing a lot more with randomization, different ways you can do that, particularly again in our footsteps. We're going to be hearing a lot of those in our games, so we want them to be nice and fresh sounding, realistic, and we will make that happen. So I think that's going to be it for this particular video. I believe the next one we're moving on to is we're going to work with some more ambient sounds. I think we're going to be working with the sounds of the water over here, and some birds. And what we're going to do is we're going to work with the different with large mode for the placement of the sounds, so that we can put the same sound file looping into various points of the map in a different way than we did with our torches. So we'll learn a little bit more about that, and yeah, that's going to be fun. So thanks for watching. We'll see you in the next one.